All right, so this is the second part of our lesson on solving rational inequalities. Now, in these problems, the rational inequalities will be of this form, where we have some polynomial, p of x divided by another polynomial, q of x. And remember, we are dealing with inequalities, so it will be something like less than or equal to 0, or greater than or equal to 0, or less than 0, or greater than 0. But it'll be in that form where you have a rational expression, you have a polynomial divided by a polynomial. All right. Now, as you go through the process, remember in our part 1 lesson, we had these steps. So we're going to refer back to these steps as well. Okay. All right. So let's look at number 1. So number 1, let's suppose we had this example. So we want to solve, and the directions will say solve each rational inequality. And you will also be asked to indicate the solution in interval notation. All right, so let's look at the first one. So we have x squared minus 2x minus 15 divided by x minus 6, and let's say less than 0. All right, now remember what you're trying to do. So you're trying to find all real numbers for x, where this rational expression is less than 0, meaning negative. So you want this rational expression right here to be negative. That's what you're asked to find. So what values of x will make this a negative number? And those would be your solutions. Okay? All right, so first step you're going to do, though, is this. You're going to factor both numerator and denominator if possible. And then you're going to find what we call zeros and what we call undefined points. So there are two things you can be looking at. So think of, and let me go ahead and do this. Think of separating this rational expression into two parts. You have a numerator and you have a denominator. Okay? So the numerator, you're going to set equal to 0, and the denominator, you're going to set equal to 0 at some point. All right, now, remember, they ask you this. It says find the zeros. And the zeros in the step says they're going to come from the numerator. Make sure you understand why. And we discussed that in part 1, but I'm going to say it again in this lesson as well. So whenever you're finding zeros, basically what you're doing is you're setting this expression here, and I covered up the less than 0 for a reason, but you're setting this expression to find the zeros. You're setting that expression equal to 0 because you're trying to find where's this equal to 0, right? And so to solve this rational equation, which you had in a previous lesson, you're going to multiply both sides by the LCD, which is x minus 6. Let me go ahead and rewrite this over. And, all right, so you're going to say times x minus 6 times x minus 6. So you're clearing the fractions. And so these divide out. And then this side 0, because 0 times x minus 6 is 0. And I want you to notice what you have. You have x squared minus 2x minus 15 equals 0. But this is the numerator, isn't it? That's the numerator. So what this step says is that to find the zeros, you don't have to go through all this step here. You just have to remember that to find the 0, you're just looking at you're going to take the numerator and set it equal to 0. Okay? All right, that's all that says. Okay, and then the other thing you got to remember in the third step is you got to find out where's that expression undefined. All right, because remember those if you're finding solutions wherever that expression is undefined, that cannot be a solution. All right, so remember if we had this, just kind of remind you, if I have 4 divided by x minus 5, this expression is undefined. Remember, a rational expression is undefined when you divide by 0. So you have some number other than 0 divided by 0. So you cannot divide by 0. So to find out where this rational expression is undefined, you got to determine, well, what value of x makes the denominator equal to 0? And so in this case, x would be 5. So that would be your undefined point right here. And so that's what step 3 is saying. So to find out where this expression is undefined, you set the denominator equal to 0. Okay? All right. So, and that's basically what you're going to do. So in your mind, you're going to say, all right, I have this rational expression. I'm going to find out where this numerator is equal to 0. And I'm going to find out where this denominator is equal to 0. Okay? So let's do that. So x squared minus 2x minus 15 equals 0. Now notice this is a quadratic equation. So in our situations, the problems that we're going to look at, when you get to this point right here, this will be factorable. So let's go ahead and factor this. So we're going to get x, what's that going to be? X minus 5, x plus 3, okay, equals 0. Then we're going to set each of those factors equal to 0 using the 0 factor property. And so I get x to be 5, x to be negative 3. Now what I found, you gotta remember what we're going to call these. These are called your zeros. These are called your zeros. So zeros are 5 and negative 3. Okay? Now we're going to take the denominator and do the same thing. So when I take the denominator and do the same thing, and that one's easy. That's a linear equation. So in this case, x minus 6 is 0 when x equals 6. But be careful. This 6 here makes this rational expression undefined. So we're going to call this the undefined point. And that's going to be important in a little while. So the undefined point is 6. So notice I have 2 zeros and 1 undefined point. Okay? Now, the next thing we're going to do is step 4. We're going to put those on the number line, and it's going to divide those number line into intervals. And then just as we did with polynomial inequalities, and just like we did in the part 1 lesson of this, we're going to use test points to determine where the interval is positive or negative. Okay? All right, so we're going to put those 3 numbers in the number line. Just remember, just like you did with the polynomial inequalities and just like you did with the problems we had for part 1 of this lesson, you need to make sure you put them in correct order. So we have negative 3. That's going to be the smallest number of the 3. Then we have 5. And then we have 6. Okay? And you don't have to space them out correctly on the number line. You just need some space here to do some work. But I do want you to notice this. So there are 3 numbers here, correct? And those 3 numbers divide the number line into 1, 2, 3, 4 intervals. 4 intervals. So this interval here is going to be from negative infinity to negative 3. The interval here will be from negative 3 to 5. The interval here will be from 5 to 6. And the interval here is from 6 to infinity. And so remember what you're trying to do. You're trying to find which real numbers will make this inequality a negative number. Any number less than 0 is negative. All right, remember, like negative 1, negative 8.6. Those are negative. Those are less than 0. Those are negative. Okay. All right. So we're going to pick test points. So we got to determine a number between the number in that first interval between negative infinity up to negative 3. So let's say negative 4. And it's always easiest to choose an integer. Integers make things easier for you. An integer between negative 3 and 5, 0 is always an easy one to use. Now 5 and 6, there is no integer between 5 and 6, so I'm forced to use a decimal or a fraction. Always use a decimal. It's easier than dealing with a fraction. And I'm going to just say 5.5. And then from 6 to infinity, let's say 7. So those are my test points. I'm putting my test points in parentheses. And now the next thing you're going to do is you're going to take each of those test points, and you're going to substitute it back into the variable and I'm going to use the factored form. So I'm going to rewrite this using a factored form. So it'll be x, always use a factored form. You can use the original problem, except you could easily mess up because you're going to have to take each of those test points and substitute where we see the variable x. But it is easier to use the factored form. So x minus 5, x plus 3 divided by x minus 6 is less than 0. So I'm going to go here and substitute. I want you to notice that there are 3 factors here. 1, 2, 3. Okay? And basically, you're just as you did before, you are going to determine the sign of each of those factors. All right, so here we go. So negative 4. So where we see the variable x, I'm substituting negative 4. So I'm going to need some room here, so let me go about right here. So negative 4 minus 5, that's that first factor, times negative 4 plus 3 divided by negative 4 minus 6. All right. Now, I don't have enough room here, so I'm going to kind of go down here. So let's go ahead and kind of look at what the signs are. A negative 4 and a negative 5 is a negative 9, so that's negative. So I'm going to put that down here. Times a negative 4 plus 3 is a negative 1, that's negative, divided by a negative 4 and a negative 6 is a negative 10, that's negative. All right, now let's simplify this further. A negative times a negative is a positive. Divided by a negative, and a positive divided by a negative is a negative. So that means, what that means is that any real number from negative infinity up to negative 3 is going to make this expression, because those are equivalent, negative. And I want that to be negative. So this interval is going to be a solution. So any number between negative infinity down to negative 3 or up to negative 3 will be a solution. So I'm going to circle that. Okay? Now let's go to the next test point, 0. So we do the same thing. Wherever we see the variable x, I'm going to substitute 0. So I get 0 minus 5, 0 plus 3, divided by 0 minus 6. All right? 0 minus 5 is negative. I'm going to put that down here. Negative. 0 plus 3 is a positive 3, so that's positive, divided by 0 minus 6 is negative. So a negative times a positive is a negative, and a negative divided by negative is a positive. So that means that any real number, so if you use, like, let's say 3.88885, and you substitute into this, that means that when I substitute that number, 3.8885, it's going to make this positive, which then indicates it's not a solution, because I want this expression to be negative. All right, so since it's positive, I'm going to put a little x there to indicate that that's not going to be a solution, because I want this to be less than 0, so it has to be negative. Now we go to 5.5. Do the same thing. 5.5 minus 5 times 5.5 plus 3 divided by 5.5 minus 6. Okay? Now, very simple. It's not difficult at all. 5.5 minus 5 is a negative number. It's negative 1/2. I'm sorry, it's a positive number. It's positive 1/2, excuse me. Positive 1/2, right? 5.5 minus 5, positive 1/2. 5.5 plus 3 is 8.5, that's positive, divided by 5.5 minus 6, that is negative 1/2, so that's negative. A positive times a positive is a positive. A positive divided by negative is a negative. What that means is that if I use any real number in here, in this interval here from 5 to 6, and I substitute into the original problem, either this one or this one, is going to make this expression, in this case, negative, which is going to be a solution. I'm going to put a little check there. Okay? And then we do the same for 7. Now, as you're going, I just want to remind you, and I've mentioned this before, don't always assume that these intervals are going to alternate. There are some mathematical problems in which they will not alternate. So don't assume if this is negative, then this has to be positive, this has to be negative, this has to be positive. All right? There are some instances where it could be negative, positive, positive, negative. All right, so always be careful. You got to show that work. And as you go and as you do this mathematically, you can easily determine later on. You can easily determine when you do more problems the situations where they don't alternate. So it's very easy to understand. Okay, so 7. Let's do 7. So we have 7 minus 5. Remember, all I'm doing is substituting back into this factor part. Times 7 plus 3 divided by 7 minus 6. 7 plus 5 is positive. It's positive 2. 7 plus 3 is 10. It's positive. 7 minus 6 is 1. That's positive. So a positive times a positive is a positive. Positive divided by positive is a positive. All right, so you know what that means, right? You know that means that any number in this interval greater than 6, when I substitute into this expression, is going to make this expression positive, so therefore it cannot be a solution. So that interval is not a solution. Okay, one final thing we got to do before we write our answer. We're almost done with this problem. We got to go back to these zeros and undefined points. Let's talk about the undefined point first, 6. Remember how we got 6? We said the denominator equal to 0, right? The denominator equal to 0. So that makes this expression undefined. A value that makes an expression undefined can never be a solution. So I'm going to put on 6, I'm going to put an open circle. Okay? Now, the zeros, and we mentioned it here, so if you recall, we mentioned it here, the undefined points will always have an open interval, while the intervals of the zeros depend on the inequality sign. In other words, does it have an equal to symbol or not? So when I go here, this is a strict inequality, meaning it's strictly less than 0. There's no equal sign. And so that means then is that right away I know that these are going to be open circles here. Okay? And then we can say our solution. So the solution is negative infinity to negative 3 with parentheses. Negative infinity to negative 3, parentheses. Make sure it looks like a parentheses. And then union, make sure you use union. Union, and then the next one is from 5 to 6. This one right here, right? So union, parentheses, 5, comma, 6. And that's it. Very simple. Not difficult at all. So what you found was all the real numbers that will make this inequality statement a true statement. All right, and there are an infinite number of solutions, of real solutions. Okay, so that's number 1. All right, so not difficult at all. Let's look at number 2. So number 2, we have this. We have x plus 4 divided by x squared plus 8x plus 12 is greater than or equal to 0. Now notice we have an equal sign this time, so keep that in mind. Okay, so remember what we're trying to do. We're trying to find all the real numbers for x that will make this expression greater than or equal to 0. Greater than 0 means positive. Positive. Equal to 0, you obviously know means 0. So I want this expression to be a positive number or 0. All right, now we got to find our zeros and undefined points. Steps 2 and 3. So let's set the numerator equal to 0. So that's how we're going to find our zeros. So we're going to find the zeros. To find the zeros, based on our previous discussions, you just basically set the numerator equal to 0. This is easy. That's linear. So x plus 4 is 0 when x is negative 4. So that's my 0. To find the undefined points, the undefined values that makes this, or the values of x that makes this undefined. So we're going to find the undefined points. So we're going to set the denominator equal to 0, x squared plus 8x plus 12 equals 0. Remember, this is quadratic, and in our problems, they will be factorable. You don't have to use the quadratic formula. So you're going to get x plus 6, x plus 2 equals 0. And you're going to set each of those equal to 0 using the zero factor property. And you get x, so x plus 6 is 0 when x is negative 6. X plus 2 is 0 when x is negative 2. So those are your undefined points. All right, and you're going to put that on the number line. So you have 3 values all together. You can put them in the number line. Make sure you put them in the correct order. So notice that all these are negative, right? All those are negative. So make sure you realize that negative 6 is the smallest of all of those. Then negative 4. Then negative 2. Just in the previous problems, those 3 numbers divide the number line into 4 intervals. 1, 2, 3, and 4. And you're trying to find out which of those intervals which of those intervals will be solutions to this inequality. Before we go on, though, let's go ahead and write this in factored form. It's always easiest when using the test points to put it in factored form. So x plus 4 divided by x plus 6, x plus 2, greater than or equal to 0. Okay, so here we go. We got to pick some test points. So let's pick any number between negative infinity up to negative 6. Let's say negative 8. Negative 6 to negative 4. Remember, you always want to use integers if possible. You don't have to. You could use decimals or fractions in that interval, but it does help if you are using integers. And the only integer that's between negative 6 and 4 is negative 5. Between negative 4 and negative 2, the only integer is negative 3. And then from negative 2 to infinity, let's pick 0. All right, so those are my test points. We're going to go back. I'm going to substitute it into the factored part. You can go back here. You just got to be careful because you see when you square negative 8, you're going to have to remember that I'm squaring a negative 8, so that's a positive 64, not negative, right? And then plus 8 times negative 8, which is a negative 64 in that case, and then plus 12. So you have to be careful when you use the original polynomials. All right. Most students, though, will go back and put it in the factored part. Now, you got to be careful because you got to make sure you factor it correctly. Otherwise, using this will make all this incorrect. So you got to be careful with that as well, with factoring. Okay, so negative 8 plus 4. So I'm substituting the test point into the original, into the factored expression, divided by negative 8 plus 6 times negative 8 plus 2. All right, I'm going to go put this down here. Negative 8 plus 4 is a negative number. That's negative 4. Negative 8 plus 6 is also negative. That's negative 2, right? Negative 8 plus 2 is a negative 6. That's negative. So I have in the numerator, that's negative. The denominator, a negative times a negative is a positive. And now we know that a negative number divided by a positive number is negative. Now remember, though, I want this expression to be positive, greater than 0, or 0. So positive or 0. So what that means in this case that I just did was that any real number from negative infinity to negative 6 up to negative 6 will make this expression negative, and so that's not what I want. I want this expression to be positive, so these are not solutions. So I'm going to cross that out. And then we go to negative 5. Do the same thing. We'll go back to the factored part. So I have negative 5 plus 4 divided by negative 5 plus 6 times negative 5 plus 2. And again, don't assume it alternates. I do want to see this work here. So you still have to show that you are substituting these test points into either the factored part or the original polynomials. So negative 5 plus 4 is negative. So I'm going to put that right here. Negative 5 plus 6 is a positive 1, so that's positive. Negative 5 plus 2 is a negative 3, so that's negative. The numerator is negative. The denominator, a positive times a negative, is a negative. And a negative divided by negative is a positive. What that means is that any real number between negative 6 and negative 4 will be a solution because it will make this expression positive, and that's something I want. So I'm going to check this off. Go to negative 3. Very simple. Same procedure always. So negative 3 plus 4 divided by negative 3 plus 6 times negative 3 plus 2. All right, now negative 3 plus 4 is positive 1. So the numerator is going to be a positive number. Negative 3 plus 6 is a positive 3. So that's that factor is going to be positive, and the factor that's in the denominator here is also going, in this case, negative 3 plus 2 will be negative. The numerator is positive. The denominator, a positive times a negative, is a negative. And a positive divided by negative is a negative. So what that means is that any real number between negative 4 and negative 2, like negative 2.008, is not going to be a solution because it makes all these numbers here will make this expression negative, but I want it to be positive are 0. So I'm going to put an x there. And then we do 0, the test point 0. 0 plus 4 divided by 0 plus 6 times 0 plus 2. The numerator 0 plus 4 is positive. It's positive 4. And now the two factors in the denominator, this first factor, 0 plus 6 is positive 6. I'm going to put positive. 0 plus 2 is positive. So the numerator is positive. The denominator, positive times a positive is a positive. And a positive divided by a positive is a positive. All right? So any real number greater than negative 2 will be a solution because it will make this expression greater than 0, which is positive, and that's something I want. All right, now we got to go and talk about those three values you put on the number line originally. Okay, so remember, undefined points can never be a solution. Can never, never, never be a solution because it makes it undefined. So I'm going to put open circles on negative 6 and negative 2. So negative 6, negative 2. Okay? Now let's talk about the 0. 0. So a 0 will be either open or closed depending on if you see an equal sign. So I see an equal sign. So remember, equal sign to equal to 0 means I want this expression to be positive, well, greater than because positive, or 0 because of the equal sign. So this negative 4 is going to be a solution. So I'll put a closed circle there. All right, and we're almost done. So our solution then is, okay, so these two intervals here, right? All right, so I'm going to say open circle in parentheses, closed circle is bracket, and make sure you clearly indicate parentheses and brackets. So you got to make sure a parentheses looks like a parentheses. So parentheses negative 6, comma, negative 4, bracket, just like this. All right, union, and then parentheses negative 2, comma, infinity. Now remember, infinity, whenever you have infinity or negative infinity, you're always going to use parentheses whether or not there's an equal sign. All right, and that's it. That's number 2. So you found your solutions. Any real number between negative 6 and negative 4, including negative 4, and any real number between negative 2 to infinity, not including negative 2, is a solution. All right, so let's do one more. So this is number 3. Very simple, not difficult at all. All right, so number 3. So number 3, we have x squared plus x minus 2 divided by x squared minus 9x plus 18 is less than or equal to 0. There's an equal sign here. All right, so again, we're trying to find the solutions to this inequality. So the solutions to this inequality will be any real number that's going to make this expression less than 0 or equal to 0. So less than 0 means I need this expression to be negative. Negative. Equal to 0 means I want it to also, a solution that also makes it 0 is a solution. Okay, so we're going to find the zeros and the undefined points. So the zeros, remember, you just said the numerator equal to 0, and those are both quadratic. So x squared plus x minus 2 equals 0. So we're going to factor this. X plus 2, x minus 1 equals 0. And I'm going to set each factor equal to 0. So x plus 2 equals 0. X minus 1 equals 0. So x plus 2, this linear equation, those two linear equations, x plus 2 is 0 when x is negative 2. X minus 1 is 0 when x equals 1. So those are my zeros. All right. Then we're going to find the undefined points. So the undefined points is where this expression is undefined. So we're going to take the denominator, find out where the denominator is 0. So we just said the denominator equal to 0. So this is quadratic as well. It is factorable. And so I get x, in this case will be x minus 6 times x minus 3 equals 0. Set each factor equal to 0. And then solving each linear equation. So x minus 6 is 0 when x is 6. X minus 3 is 0 when x is 3. So those are your undefined points. And those you have 4 numbers this time that you're going to put on the number line. So it's a little bit more work you have to do because you have one more test point to deal with. Make sure you put them in order of the number line. So the only negative 2 is the only negative number, so that's going to go here. And then we're going to put 1, 3, and 6. So 1, 3, and 6. All right. Now, let's go ahead and rewrite this in factored form because it's always easiest to put the test points in the part that's factored. So, but again, as we mentioned before, you got to make sure you factor this correctly. Otherwise, all of this is going to be incorrect. So x plus 2, x minus 1. The denominator is x minus 6, x minus 3, less than or equal to 0. Now remember, you want this to be negative or 0. And then right away, if you want to go ahead and put the close or open circles on these numbers right now, you can. So remember, undefined points, these values make this expression undefined, so they cannot be a solution. So put open circles in 6 and 3. So here and here. Since there's an equal sign, those zeros will be solutions because that's how you got those zeros, by setting that equal to 0. So negative 2 and 1 will be closed circles. So closed circle, okay? All right, now let's do the test points. So a number between negative infinity up to negative 2, let's say is negative 3. Between negative 2 and 1, we're going to use 0. Between 1 and 3, the only integer is 2, so let's use that. And from 3 to 6, we could use either 4 or 5. And when I say we could use either 4 or 5, that's because I want to use an integer. But you do realize that there's an infinite number of real numbers here, so you use any real number you want to as a test point that's between 3 and 6. But I'm going to use 4. And then greater than 6, let's use 7 or 8 or 9, whatever you want to. All right, so those are my test points. And now what we do, it's a little bit more work because you have 4 factors here and you have an extra test point to deal with than you did previously. So we got to take each of those test points and substitute into these 4 factors. So let's go ahead and do that. So negative 3, we have negative 3 plus 2 times negative 3 minus 1 divided by negative 3 minus 6 times negative 3 minus 6. Oops, I didn't mean that to be 6. That's what? Minus 3, excuse me. Minus 3. So be careful when you transfer, because I noticed I did make a mistake. Sometimes many times you can, when you get to that point, you can easily figure out you made a mistake when you wrote it over. Sometimes you can't, so be careful. All right, so we got 4 factors. So this factor is going to be negative. Negative 3 plus 2 is negative. And put that down here. This factor, negative 3 and a negative 1 is negative. It's negative 4. Negative 3 and negative 6 is negative. It's negative 9. Negative 3 and a negative 3 is negative. It's negative 6. In the numerator, a negative times a negative is a negative. So that's a negative times a negative is a positive. So that's positive. The denominator, same thing. Negative times a negative is positive. So that's positive. And so a positive divided by a positive is a positive. So what that means is that any real number between negative infinity and negative 2 will make this expression positive. So it means that any real number between negative infinity down up to negative 2 is not a solution because I want this to be less than 0, negative. All right, let's go to 0. Do the same thing. 0 plus 2, I'm just substituting 0 for x, times 0 minus 1, 0 minus 6, 0 minus 3. 0 plus 2 is positive, positive 2. 0 minus 1 is a negative 1, so just put negative. 0 minus 6 is a negative 6. 0 minus 3 is negative. A positive times a negative is a negative. A negative times a negative is a positive. A negative divided by a positive is a negative. So what I found is that any real number between negative 2 and 1 will make this expression negative, which is what I want. So that interval is going to be a solution. So I'm going to put a little check here to remind me it's going to be a solution. Go to the next one, 2. So we have 2 plus 2 2 minus 1, 2 minus 6, 2 minus 3. 2 plus 2 is positive 4, so positive, times 2 minus 1 is a positive 1, so a positive. In the denominator, those two factors, 2 minus 6 is a negative 4, so that's negative. 2 minus 3 is a negative 1, that's negative. So a positive times a positive is a positive. A negative times a negative is a positive, and a positive divided by positive is a positive. So this interval is positive. So that's not good. So the real numbers between 1 and 3 are not going to be solutions because any real number I choose is going to make this expression positive, but I want it to be negative or 0. Then we go to 4. Do the same thing. I don't have enough room here, so I'm going to go down here. So we have 4 plus 2, 4 minus 1, divided by 4 minus 6, 4 minus 3. 4 plus 2 is a positive 6. That's a positive. 4 minus 1 is a positive 3. So that's positive. 4 minus 6 is negative 2, a negative. And then 4 minus 3 is positive 1. That's positive. All right, the denominator, positive times a positive is a positive. A negative times a positive is a negative. And a positive divided by a negative is a negative. So the question becomes, is this interval here going to, or the real numbers in this interval going to be solutions? And the answer is yes. Because every real number here makes this expression right here negative. So I'll put a little check here. And then we do the next one, 8. So in 8, and let me go ahead and do that here. We have 8 plus 2, 8 minus 1, divided by 8 minus 6, times 8 minus 3. So I saw the variable x, I substituted 8. All right, now let's go ahead and look at the signs of each of those 4 factors. The numerator here, this factor, 8 plus 2 is positive 10. That's positive. 8 minus 1 is a positive 7. That's positive. 8 minus 6 is a positive 2. That's positive. 8 minus 3 is a positive 5. That's positive. Positive times a positive is a positive. The numerator is going to be a positive number because a positive times a positive is a positive. And a positive divided by a positive number is a positive number. So what we now know about the real numbers in this interval is that those are not going to be solutions because any real number here makes this expression positive, but I want it to be negative or 0. All right, and we're done. We just got to indicate what the solution is. So there's your work, all of this. And so the solution will be from negative 2 to 1 and from 3 to 6. But don't forget, closed circle brackets, open circle parentheses. So bracket negative 2 to 1 bracket, union, and parentheses 3 to 6 parentheses. Okay? Make sure your brackets look like brackets and your parentheses look like parentheses. And that is it. So any real number between negative 2 and 1, including negative 2 and 1, and any real number between 3 and 6, not including 3 and 6, are going to be solutions to this inequality. Now, these are identical, so you can say either this or this. All right, so that is the 3 problems on the part 2 on solving rational inequalities.